Welcome back to another geometry puzzle. Today's problem is especially fun because I'm going to show you two completely different ways to find the answer. Let's look at the diagram. We have a circle with center O. Inside the circle is a horizontal chord, AB. A vertical line segment, CP, intersects the chord at a right angle. Now let's look at the given measurements. Segment CP is 8 units long. Segment AP is 4 units. And segment PB is 44 units. Our goal is to find the radius of the circle. Let's begin with the first method. Extend segment CP downward until it meets the circle again at point D. This creates a complete chord, CD. Let's call the unknown segment PD X. Now we can apply the intersecting chords theorem. When two chords intersect inside a circle, the product of the two segments of one chord equals the product of the two segments of the other chord. So, 4 multiplied by 44 equals 8 multiplied by x. 4 times 44 is 176. Divide both sides by 8, and we get x equals 22. Now comes a beautiful shortcut. Whenever two chords intersect at a right angle inside a circle, there's a very useful formula. 4 times the radius squared equals the sum of the squares of the 4 chord segments. Our 4 segments are 4, 44, 8, and 22. So, 4 times radius squared equals 4 squared plus 44 squared plus 8 squared plus 22 squared. Let's calculate those values. 4 squared is 16. 44 squared is 1,936, 8 squared is 64, and 22 squared is 484. Adding them together gives 2,500. So, 4 times radius squared equals 2,500. Divide both sides by 4, and radius squared becomes 625. Take the square root, and the radius is 25 units. Now let's solve the same problem a completely different way. Suppose we draw a perpendicular from the center O to chord AB. Let the foot of the perpendicular be point M. A perpendicular from the center of a circle always bisects a chord. The entire chord AB is 4 plus 44, which is 48. So M is the midpoint, and MB is 24. Since AP is 4, PM must be 20. Now do the same thing for the vertical chord CD. Draw a perpendicular from the center O to chord CD. Let the foot of that perpendicular be point N. The length of chord CD is 8 plus 22, which is 30. So, ND is 15. Also notice that ON and PM are equal. So, ON is 20. Now connect the center O to point D. We get a right triangle. One leg is 15, the other leg is 20, and the hypotenuse is the radius of the circle. Those numbers should look familiar. 15, 20, and 25 form a scaled version of the famous 3-4-5 right triangle. Since 3 becomes 15 and 4 becomes 20, the hypotenuse must be 25. So once again, the radius of the circle is 25 units. Which method did you like better? The first one or the second? Let me know in the comments. Thanks for watching, and I'll see you in the next video.